Herr Simondetti ist der Global Leader Virtual Design bei Arup mit Sitz in London, UK. Er ist in Italien als Architekt ausgebildet worden, hat Architektur, Stadtplan und Denkmalschutz und Computation gemacht, ist mit einem Fulbright-Stipendium an das Massachusetts Institute of Technology gegangen, hat eine Assistenzprofessur bis 2000 gehabt an der Hong Kong Polytechnic University und ist seit 2000 bei Arup und dort verantwortlich in der Geschäftsentwicklung synthetischer Umgebung, und er ist seit 2011 Mitglied im Aufsichtsrat von Autodesk Ideas. Wir werden ein wenig die Technik umbauen und ich habe gehört, ich habe auch eine kleine Aufgabe. And as soon everything is correct here, I think you can start. The floor is yours. Does it work?
No, not yet.
Not yet? What's missing? The picture. Oh yes, no picture.
Okay. Thank you very much for the introduction. Thank you for the opportunity to speak to you in the last spot of the day.
So you're a little bit more free if you...
Excellent. Thank you. I don't have to... my name is Alvise Simondetti. I work in Arup in the Foresight team, and I was asked to finish the day by looking further forward, and I took the request at heart, and so I want to present to you a future about the Foresight team focuses on 10 years plus, and we really focus on 10 years plus. Every time we do something with parametrics or digital fabrication, our colleagues say, "Why do you do that? That's our business." Every time we integrate a few tools together, our colleagues say, "That's not the future. This is what is the present now." So the future is going to be participatory, and hence, if the image is now connected, oops, maybe not, and is also not completely working.
It works.
No, I wanted to.
Here? Is this the right picture?
Yeah. I think that we are going to, I wanted to, is your thing? Not connected yet. Okay. So the future is a little bit not completely connected. We are going to skip that bit. Introduction. I was a student of Dennis Sheldon. So it's a pleasure and a challenge to follow him. I was at MIT in 97, so about 20 years ago. And at MIT there were two major trends going at the time. One was the trend of automating design. You see on the top right of the image, top left of the image, and the other one was digital fabrication. So I wasn't that happy with expert systems, so I worked with my colleagues. They were doing the expert systems, and I focused on digital fabrication. I then moved on to the academia before joining Arup in 2000, and I spent 3 years setting up a big virtual reality center. It was the 500 set up in the world, but it was the first one in a school of design. So enabling what if you can enable designers to experience at full scale, in full detail, before it's constructed. And I now, my role at Arup is now, leading the Digital Environment Skills Network. So this is a community of practice that unites all of the practitioners in the area of digital environments. Not too dissimilar from buildingSMART, but within the company. So we started in 2 people as a good community starts, and then we moved on to now around 2,000 people. Arup is about 10,000, and I'm always wondering what the other 1,300 or 13,000 are doing. So within this community, we spend a lot of time getting people together, but because we are funded by our bosses say, so what are you going to deliver? And so we eventually, a few years ago, we set up a TED-like platform. You see the image there, very limited. So our TED-like platform has a budget of £500 as opposed to a bigger budget maybe for TED. And what we do is we collate and promote the work of our friends. So I lead that platform. What it means that I go around and oh, it's working, perfect. And I'm gonna, and I check the best practice that our colleagues do around the world, and then I collate it and I upload it to the server. I'm gonna tag it by hand, and I'm gonna promote it. And so, excellent. So it's actually a good time. So I'm going to talk about, I told you these details because it will become obvious in a second. I'm going to talk about 3 projects, and the first one is crowdsourcing design feedback, so we can change the screen. And this is a jump into the future. So in the future is going to be participatory. So I would like, kindly, Thomas said that he's going to participate in this game for me, and he's going to work on this task. So,
I start?
Yeah, you click it. So I'm going to help you by, in the future, you will also have, before you move.
I go to South Island
No,
line?
I'm going to put your name in.
Oh.
So, in the future, everything will be recorded. And so we are recording your name. And now you have to do a task. Your task is to find the South Island line. Yeah? Maybe the lights should go off on the stage. Excellent. So this is a project that we completed around 2011.
Where is it?
Oh, you got already lost.
I got.
It's so well designed, the station. You should never get lost. So you go left. Keep on going left, 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 down the yellow wall. If you go down, follow the yellow wall on the left. Okay. So what Thomas is doing is post-occupancy evaluation, pre-construction. So he's evaluating the wayfinding and the signage of the station for us, and he's doing pre-construction. So I'll give you an example, just a couple of words on the challenge of the station. The station is it's an extension, is Admiralty Station in Hong Kong. It challenges, I mean, it moves, it has 1 million journeys, passenger journeys per day. So it's a very busy station. It has 2 lines, 4 platforms. You're doing very well. And you're doing too well. It seems like it's properly designed. Go to the right, yeah, excellent. And not down the upwards escalators. And is designed to extend to 4 lines, 8 platforms. So the complexity, most of the journeys now are cross-platform. In the future, this station is under construction. The first phase is going to be open end of this year, which is the South Island line, where Thomas is going to take us. And the complexity is increasing exponentially. So thank you. Oops, one little bit further. Well done, excellent. So we switch back to the slides and the light, thank you. Oops, here. So we call it crowdsourcing design feedback. What you see here is an image of the station with all of the journeys traced. So, and I'm going to take you, this presentation is about the future. And in the future, we think that the biggest change that we will have is a change in approach. And I'm told that changes in approach are very difficult. We have a head of learning at Arup, and I asked David, how do I make my colleagues change their approach? And he said, oh, Alvise, you know, changing mindset, changing approach is a difficult thing. It's going to take 20 years. And I said, David, I don't have 20 years. So he said, well, there is another way to do it. And the way to do it is to shock them. So I'm going to try and shock you for the rest of the talk at the end of your full day of business today. So here you see the 4 steps, the 4 different approaches. One is wayfinding with the layout. This is, I'm talking about wayfinding, but I like you to think further on any aspect of design. And I also like you to think of design as the way that is proposed in Arup, which includes design, operations, and any decision that people make. So just about everything. The results, so on this station in 2011 or 2012, we adopted already a more advanced way of designing. So we had an expert, Karen, and Karen worked with the environment that you just seen, that Thomas used, and she has the results that she had is that we had from the client, our role on the signage was it was a technical advisor. So we had version 18 of the design. The client worked about a year and a half on the design of the signage, about 1,000 signage in the station. She found 25% error, and of that error, the client accepted 15% because the signage design is not a science, but is an art. I have no idea how many of you are architects and how many of you are engineers. How many of you are architects, if you raise your hands? Yeah, there is a good quantity. So you will see that there is a lot of part of the work that we do that is not defined. And that has been the challenge in going to digital, to say the least. So I'm going to now give you some results. So when we finished that work in around 2014, we had done some work with the Biennale in Venice. That year was curated by Rem Koolhaas, and Rem Koolhaas saw the simulator and said, why don't you take it to our escalator room? So we did, and that was, and so what this is what it looked like in Venice. We had it there for 6 months. We put a little bit of reward, and we asked people to do effectively what Thomas has done with us, to find the South Island line, and to our amazement, this is the way it looked like. You see the reward. It was a very small reward mechanism. It's just recording the time and doing a scoreboard. And to our amazement, we captured more than 1,500 journeys. So this is, it was completely new. Nobody knew what it would have been the outcome. The Biennale had 200,000 visitors. Many more people used the simulator, but 1,600 started following our journeys. So we then used the data, and we tried to emerge the challenges of the design from the data. So you see the implications, right? This across the profession. It means that if data can tell you the challenges, then you don't need experts anymore. More of that to come. So here's the first challenge, pretty obvious one. Everyone gets lost, including Thomas, at the beginning of the journey where there is a missing sign. Some people go straight for the missing sign. Some people behave differently and go around in circles. Most people do so. This one is a little bit more complex. The sign is there, but actually people stop because they don't see where the sign is pointing to. So most of us follow, but some don't. Here is another example. This is a lot of people. So you see the data is telling us where the problem will be, and then we refer to the expert, and the expert told us the problem there was that there was two overlapping set of signages that are conflicting, and so people stop in front of conflict. This is the last example. Down the escalator, the sign is right in the right place, its existence. What's the problem there? The problem there is that it's a three-dimensional environment. I can't speak and move the hands at the same time. It's a three-dimensional environment, and so the sign appears too late, and people take a few seconds to actually to make a decision. So the journeys that you saw in red, we were addressing an expert, preconceived expert idea challenge, which is slowdowns in stations. And we decimated the data just to show that bit of information that refers to the challenge. Now, here is the full data set with all the people that got stuck and the one that didn't. So I'm going to move on to the next project, and we will pick it up towards the end. The second project I want to talk to you about is this, the Foresight team does, are this exploration. So we found that the AI and machine learning was becoming hot. You all seen all of these things, and you also probably been aware of the fact that the future of the employment looks very bleak. So this is the most cited paper on future of employment by two statisticians. They use statistics to predict the likelihood of your profession, of all professions, 702, to be replaced by computers. And this is by 2030. Yeah? So it's fairly close. So what is the profession that is most likely to be replaced by machines? Any guess? Anyone wants to guess? The future is going to be participatory. You have to tell the machine answers. If you don't speak to answers, machines will be not very useful to us. Anyone wants to guess? Too many people? Always there is someone guessing. What's the most likely profession? I'll tell you, it is the taxi drivers, according to this paper. And what is the least likely to be replaced? This works much better as an interactive thing. Anyone wants to guess what's the least likely? 0.1% chance to be replaced by machines. It turns out to be nurses. Yeah, nurses use empathy. They care about you. Machines will never get there, according to them. And they also use dexterity. So they work with their hands. It's going to be unlikely that a robot will turn you around when you are in the last stages of your cancer. And if you look at the New York Times, they call it be nice, and be good with your hands. And they add one more, which is creativity, and I'm not quite sure about that. So what is machine learning? I take a long time to explain it, but here is John, and John explains it in 1 minute, and I like to play this.
First of all, let me try and give you my sort of super simplified view on what machine learning is, because it's a whole class of different algorithms and techniques. But if you contrast it against more traditional techniques, the classical approach is you start with a model, and it could be something very simple like this normal distribution or something complicated out of thousands of components. And the role of data is to check if that's valid and to calibrate it. So we look at the data and we improve our model, and then we decide that the model is now as good as it's going to get, and features that we might not be able to explain and noise, which we aren't interested in, we throw away because now we have a perfect model. The machine learning approach turns that on its head, and it throws away the concept of a model, and we just look at the data, and noise and features are treated identically. The key attitudinal change you have to make is the data is the model. Now, some model actually gets constructed inside the machine, but that's something that basically we shouldn't care about if we're thinking in terms of machine learning.
Great. So what's the implication? The paper, the Oxford paper also says that domain expert and market expert will be redundant and may become detrimental. And by the way, for those of you that are in the world of computer software, it also says that human-conceived algorithms will be redundant and may become detrimental. It comes as a consequence of what John just explained. So why is this, of course, is of great interest for our company, and that's why I came here and I wanted to show you that the future is going to be disruptive in many different forms, and machine learning is probably going to be one of the biggest disruptors. What machine learning does for us, it makes our designs more appropriate, more timely, more scalable. Once you have those three things, you're just about as competitive as you can, and it's going to be really hard to compete with those guys. When is it going to come? I'm going to have to speed up. It's going to come maybe a year, maybe a year and a half. That's what Gartner says. And now I'm going to show you a number of applications. Also gives you a sense of how close we are. So our colleague Jeffrey, he's a serial entrepreneur in Silicon Valley. He says everything will be recorded. Of course, our talk is recorded as we speak, and I hope to have a copy afterwards. So this is what machine learning does to our recording. You remember that that whole TED-like library that we have inside the company. I gave it to Jeffrey, and Jeffrey ingested it into their machine learning system. And this is where the machine learning chopped the whole video into little sentences and did some analysis, and it also did automated transcription. So transcribers are also another profession that is gone much before 2030. So this is the human-made transcription. And interestingly, I sometimes like to joke that if we fast forward another 50 or 60 years, we are back to tablets, right? This is what the HP machine learning says. If you try and read that, it makes no sense. That's about 60 to 70% right, and it's not good enough. However, and here we have, maybe Claire is still in the audience, IBM Watson does 85% accuracy on transcription. And if you read it, it says, interestingly, I sometimes like to joke that if we fast for another 50 or 60 years, we were back to tablets. That's good enough. So this is my platform, human-made, with a lot of effort, always late, and with tags that are generally inappropriate and not scalable. And here is what it looks like once it's machine learned. So all of the clips on the left-hand side are all the clips. What you see at the bottom is the 85% accurate transcription. All the keywords are automatically generated, and as you click them, it learns which one you like the best, and it goes to the top, like your Google, etc. The concepts are more sophisticated keywords, and if you actually click I like into the heart on the top right, this will be you inputting. Then we can actually figure out which bit of the talk is the most people most like. What does this allow us to do? It allows us to do non-linear consumption of videos. So TED Talks are very cool, but who has the time to watch a TED Talk? However, if I could look at TED Talks according to, I don't know, blockchain, wouldn't it be cool to know who the TED Talks sentences that refer to blockchain? Well, with Ted Watson, you can actually do that. Not quite as good as ours. And that is a huge thing that we couldn't do before. I'm going to give you another example of what we couldn't do before. So this is Autodesk. Autodesk, I think, is here, certainly here as a big supporter and sponsor. So Autodesk has been learning nuts and bolts literally, as opposed to figuratively. And what they learn actually 400,000 nuts and bolts. And soon they have a platform for a mechanical called Inventor. A lot of us know Inventor. It has moved into the cloud and is now called Fusion. Inside Fusion, you have, or you will have shortly, machine learning. What is going to look like? Is going to look like this. You type in a search, it gives you a solution, and it doesn't only give you one solution, it gives you all the solutions that are relevant to that. If you draw it, then it will match the mesh and it will find the other nuts and bolts that are similar. And that you can then classify them for most sustainable, cheapest, most locally sourced, and etc. This is already in the software. I speed up. So we talked about what you couldn't do before. Really exciting for our buildings to be able to have this last minute most relevant, timely solutions. Now, what you can do, what we could do better than we could. So, how can we use machine learning to make to do better, cheaper, faster? I mean, better and cheaper and faster, as opposed to one or the other. So here is our colleagues at MathWorks. I asked them what is the most productive application. They said, well, predictive energy optimization is not bad, 25% total energy consumption. So we just recently came in the press that Google data centers, I don't know how many of you have seen it, Google data centers are using machine learning, and they are in order to run their data centers, and they are doing 40% reduction in cooling loads and about 25% in total reduction. So how do they do that? They predict when the peak usage will be. And the peak usage is your kids watching YouTube. And when you just before the peak, you pre-cool the data center so that when the peak comes in, there is you are not firefighting, but you are doing it ahead of time. The other thing is, have you ever done a false claim to an insurance? Well, if you have, watch out, because they use machine learning and they can actually predict with 92% accuracy whether your claim was a false claim. So don't do it anymore, at least if you have RAC as an insurer. So what does it mean to our colleagues at Arup? Our colleagues in the lighting team, they do a lot of prediction of what the light will be in a certain building. So what you can do is you can do normal simulation. We call it deterministic simulation for the sake of discussion. And so you create a nice 3D model and you put a opaque sky outside and you predict what's the light inside the building. What if you do machine learning? Well, if you do machine learning, it's a probabilistic approach. Actually, with 500 samples, you get a pretty good model, a neural network that represents pretty much the reality. And that way, you can predict the lighting level inside the building. So it's a complete different approach. It's probabilistic versus deterministic. And it is actually giving you a shorter way to the same prediction. But what if we are talking about not lighting, which is highly deterministic, but we are talking about glare? Glare, it turns out, that is very hard to compute in a deterministic way. So the state-of-the-art formula, as it says there, is 60% accurate. This is what the machine learning model looks like. John talked about the fact that there is a model, but we just can't read it. So you see the previous model is very easy to read for those that know how to read that. And the machine actually has a model that is not easy to read. What is the result? Well, the result with just a small amount of samples gives us 83% accuracy in predicting what glare will be in the building. Back to our project, I told you I was going to come back. Machine learning is the next step. So if we take all data, not just the data that the expert wants to see, what we can do is we can predict the speed at any point in time in the station. Turns out that that's pretty stupid, because given that we use the joystick to navigate the station, when we found the speed, we went back to the formula that we used in the first place, which is go or stop. So watch out, if you machine learn something, you have to have real data and they have to have high richness. The other thing is that we can do, though, is we can decide how people behave in the station. And so we can develop a certain wayfinding language that we can then use in the prediction of our designs. Last example, and for those of you, you remember at the beginning I said that my passion was digital fabrication, and I left the automation of design to my colleagues. Well, look at this. So this is very new, just a couple of weeks ago. It was exhibited at a conference in Amsterdam. It's the Daedalus Pavilion, built by the team AI Built. They are a spin-off from UCL in London, the university. And this is what machine learning does. So this is so you have never seen a 3D print of that size, right? So this is a 3D print in plastic, and it is huge. It's 6 meters by 6 meters by 6 meters. How could they do it in a pragmatic way? Well, the way they did it is they actually put a feedback loop at the end of the robot arm, which was, by the way, KUKA, in case KUKA are in the room. We are good friends, great admirers of German robots. So the KUKA robots had, at the top of his head, they had a sensor, and the machine will print a piece in an adventurous and fast way, and it will then correct itself and continue. Print, watch where it's gone to, correct and continue. And that way the machine has been able to print in a reasonable amount of time and this big pavilion. I kind of like, for those architects of you in the room, I kind of like the aesthetics. It looks a bit like the jumper knitted by your grandmother versus a machine knitted jumper. Is this inevitable? Well, it's up to you to decide. Last project, because Remkulas doesn't always invite us to the Biennale in Venice, and we have thousands of projects, we looked at for help, and we looked at the help of 3D Repo. So now we have the station. I'm just showing you screenshots. This is now, the station is now online in 3D, and with a name and a password, anyone can navigate through the station. And so we can do post-occupancy evaluation, pre-construction on all our projects. This is specific for this audience. I am not an expert. Joseph did his PhD with me. At some point we were talking about interoperability, and he said, Alvise, when I get your geometry, I upload it into my server and I translate it in all the languages that I need in order to download it. So we talked, Patrick talked earlier about the role of creating a dictionary for the industry. And he earlier talked about the idea of a dictionary being overtaken by Google search. So this is an open question to all of you guys. I think in the short term we certainly need a dictionary, but we'll need to watch out for these machines that seem to know all languages. 3 projects, and thank you for the opportunity to discuss with you. Very interested in your questions, your comments. You have the email there. Please contact us with your reactions. We don't know what the future is. Foresight team is only laying out plausible futures, so we need your reactions in order to fine-tune and understand further. Thank you.
Thank you. Thank you very much for giving your insight in the way you think design processes will work in the future. Is there like a tendency that in the future we will design not from the outside of a building, but more from the inside of a building? I mean, you just made me run around in a fictional building and figure out the proper way the building has to be designed.
Yeah, thank you. It's a very interesting point, and I'm not very good at prophetizing the future. So despite being in the foresight, not very good. So I think that there will be certainly people working from inside out, especially if you do what we call operationally driven design. So hospitals, stations, all of that. That's it. If you are going to do a more a different design, maybe so then you may still continue designing from the outside in. And we saw some amazing examples earlier in the day of designing from the outside in that I wouldn't want to predict that they finish.
Mm-hmm. We're running out of time. I'm sorry, only one question to you. Thank you very much. Last applause. Thank you.
Thank you.